Hello, this is Miss Cliffner with your lesson for today. It's about whole number operations, which you've been working a lot with in elementary school. But today's lesson has more to do with how you figure out which operation you're supposed to use based on word problems. So there is a warm-up that asks you to put in some words that might mean addition, subtraction, multiplication, and division. So I'm going to skip that just in case I don't do it in next year's lesson. And just notice that there are multiple ways to show multiplication and division, but really, when you're subtracting or adding, right, you put the little plus sign, you put the little minus sign. You could do this, and you could set it up to work with it. You could put the 5 on the top and the 2 on the bottom, and that's how you show addition and subtraction. And for multiplication, you've been used to seeing an X for times, but we're going to use a lot of other symbols that also mean multiply. There's a dot that means multiply. And then there's a parentheses. The 3 is enclosed in parentheses, and there's a number 2 next to it. And basically, we started, instead of doing an X, we dropped it down to the dot. But then mathematicians also thought maybe it's a cool idea if we show a number in parentheses, and if it's next to another number, that also means times. And then you don't really have a dot on your keyboard, but you do have this asterisk symbol. So if I did 2 asterisk 3, that also means times. And it's shift 8. So for division, right, this is the division symbol. This is a fraction bar, right? So I call this a division symbol. And this is a fraction bar, which could mean a fraction, but it could also mean division. And then you probably are familiar with seeing the little, I call it a den that's set up to do some long division. Okay, so for today's lesson, notice that, let's go ahead and put me down there. Here's a bar graph at a festival showing you attendance over 3 days, right? So if I look on the horizontal axis, it says day 1, 2, and 3. And if I look on the vertical axis, it says the number of people. Now, what I like about this graph is they actually showed you the exact numbers at the top. And a lot of times with bar graphs, it's hard to tell the exact number. So you can see the exact number there. And the first question says, what is the total attendance for the art festival? I want you to underline the word total. In word problems for my class, I like to underline the math words and I circle the numbers. Well, I've already circled the numbers at the top of each bar graph. And total means that you're adding. Now, total doesn't always mean that you're adding, but in this case, you have a day 1 total plus a day 2 plus a day 3. And I find it easiest to add 2 numbers at a time. You could add 3 numbers at a time, but I thought maybe I'll just add day 1 and day 2. I have my place values all lined up, and I start with the ones place, and I get 5. I add the tens place, 7 plus 4 is 11. I put my 1 there, and I regroup the 10 up there, the 10 plus 1 and 11. And then I have a 1 plus 1 is 2, plus 5 is 7. 2 plus 3 is 5, and then I go ahead and I could put a comma there. But wait, I have to also add the last day's attendance. So I have 7515 plus 3, 8, 7, 6. 5 plus 6 is 11. Oops, let's make sure they can see that's a 1 plus 1 is 2 plus 7 is 9. 8 plus 7 is 15. Regroup the 1. 5 plus 3 is 8 plus 1 is 9. So my total is 9,591, and it's a word problem, and word problems always have words with them like the units. And so the units for this is people, right? We were measuring the number of people. So I'm going to say this is my answer, 9,591 people. Okay, the next question says, what is the increase in attendance from day 1 to day 2? Now, increase in general means to add, right? But if you don't know what to add, if you know there is an increase, there's more that's been added, you have to work backwards and subtract. So if I look at the day 2 attendance, it's the 3,145. There's the day 1. I need to subtract day 2 and day 1. I line up the place values. I check before I do my subtracting to see if there is any regrouping I need to do. So notice 0 is smaller than 5, so that column's good to go. 7 is not smaller than 4, so I'm going to need to regroup. This is going to get a little tricky. I've got a 1 here. I'm going to regroup from this 1. When I do that, I'm going to take one of the 100s, which means I have 0 in the 100s place, and I'm going to cash it in for 10 tens. So now I have 14 tens. I can do the 1s. I go back to the 100s. I can't take 5 away from 0, so I have to go to the thousands place. Cross off the 3. I'm taking one of the thousands and I'm turning it in for 10 100s. I already have a 0 there, so all I need to do is put my 1 in front of it, and you can see that I have 10. Now that I've done all my regrouping, I can subtract. 5 minus 0 is 5. 14 minus 7 is 7. 10 minus 5 is 5. So there are 575 more people. That's the increase. Okay, next. Now here's an OYO. When I do OYOs, that means I'm asking you to pause the video and try this question on your own, and then unpause the video and see if you got it right. So here's attendance, 2,118 people. The next year, there was more attendance. What's the total number of people who attended in those years? Okay, so total means I'm going to be adding in this case. I'm not trying to find out how much more. So I take the 2118 and I add the 3391 to it. So I get 9. 9 plus 1 is 10. Regroup. 1, 2, 5, and 5. So there was a total of 5,509 people. All right, next. You notice the example says multiplying whole numbers. Let's see if it is about multiplying. A school lunch contains 12 chicken nuggets. I'm going to circle the 12. Oops, let's do that one again. 25 students buy the lunch. I'm going to circle that. I'm just going to put a 25 next to it because sometimes if numbers are written out in words, I like to see the number. What is the total number of chicken nuggets served? Okay, notice there's a total again, but this time the total means multiplying. So picture there is 12 nuggets on this tray, and then 25 students go through the lunch line, so they've served 25 students each. Ooh, did they have an each in this? Nope. They just had the word total, but I'm picturing 12 times 25. So I'm going to set it up the way I set up long division. I call it long multiplication. I put the 25 on top. I put the 12 underneath. It's times. I'm going to multiply the 2 times 5, then the 2 times 2. 2 times 5 is 10. I regroup the 1. 2 times 2 is 4, plus 1 is 5. Now, I've multiplied 2 times the 25 students, and I got 50. That's a partial product. Now I also need to multiply the 10 times the 25 students. But it's in the tens place, so before I start multiplying this 1 times 5, I have to put a 0 there. 1 times 5 is 5, and 1 times 2 is 2. Okay, 0, 1. All right, so it looks like 300 chicken nuggets were served. Okay, here's an OYO. Pause the video. Try it. There are 15 boxes of peaches, and each box, each is a word in math that sometimes means multiplication or division. So sometimes I'll put a note to myself and figure out which it means. Contains 45 peaches. All right, so this is like the other problem. I'm picturing 15 boxes, and in each box there's 45, kind of like the nuggets. There was 12 times the 25 students. So this is going to be 45 times 15. And I do the 5 times 5 is 25, regroup the 2. 5 times 4 is 20, plus the extra 2 that's up there is 22. This 1 is really a 10, so I need to put a 0 for the place value. 1 times 5, 1 times 4. 5, 7, 675 peaches. That's a lot. All right, next. Oh, well, here's a big clue up here. It says dividing whole numbers. I wonder if this will actually be division. I'm going to move this over so you can see that. And I'm going to just go ahead and erase that. You make 10 equal payments for a go-kart. Ooh, okay, let's circle the 10 And I'm going to underline equal payments, right? Equal usually means a fair share or dividing. You pay a total of $840. How much is each payment? So here's a total. Okay. So I can picture that I'm taking the total that I have to pay and I'm dividing it. I'm going to put my little division symbol up here. I'm going to divide it into 10 equal payments. So what I want to do is 840 divided by 10. If you're not good with dividing by multiples of 10, we're going to practice things like that. But 10 goes on the outside, 840 goes on the inside. And then if I can't divide 10 into 8 because it's bigger, I can put a 0 or I can put an X. But I do know 10 can go into 84, and it goes 8 times. 8 times 10 is 80. I multiply, and then I subtract to see what I have left over. I have a 4 left over, and it stands for 40. So I'm going to bring down the 0. Now you can see that it is 40, and 10 goes into 40 4 times. 10 times 4 is 40, and when I subtract, I have no remainder. So you make payments of $84. All right, last OYO, an amusement park. There's a total of 96 people that rode a roller coaster, or that ride a roller coaster. Each coaster car can hold 4 people. How many cars are needed to hold all 96 people? I'm going to underline all 96 and circle the people. So I'm picturing a whole group of people, and I'm chunking it into groups of 4 because 4 people are in a car. That tells me that it's 96 divided evenly by 4. 4 goes on the outside, 96 goes on the inside. 4 goes into 9 2 times. 2 times 4 is 8. I have 1 left over. That's a group of 10 people. I bring down the 6 ones. 4 goes into 16 4 times. 4 times 4 is 16. I don't have any people left over. I need 24 cars for all those people. Okay, that's it. Good luck with your homework.